Hello everyone, it's me Sanjay Vasu back again for another video. This time I'll be doing it on the Cambridge IGCSE Mathematics Paper 2, which is a non-calculator paper for extended maths for examinations from 2025. Before we go to the questions, let's just take a note of the list of formulas which is given on the front page right after the page with the name and details of the candidate. These are the important formulas which you will require for the exam and therefore is always given in this page. Let's start. Question 1. Work out 0.01 whole squared. That's just going to be 1 by 100 squared, which is 1 squared over 100 squared. That's 1 over 10,000. And in decimal form, it's just 0.0001. A useful strategy for squaring these numbers, if you don't know how to do it directly in decimal, just convert it to fraction. Convert this decimal to a fraction, square the numerator and denominator separately, and then bring it back to a decimal if you can. Question 2. Write 57.3997 to 4 significant figures. The fourth significant figure is the first 9. The fifth one is the second 9, which is greater than 5. So we have to add 1 to the fourth significant figure. But that becomes 10, and 10 cannot fit in one digit. So the 1, this place value here, will be shifted to the next digit, the third significant figure. So it's going to be 57.4. But this is the wrong answer. Why? That's because we need 4 significant figures. But if you look at 57.4, it only has 1, 2, 3. Well, we don't have another number to place at the fourth one because 57.4 is the answer. But then we have to place a 0 there. This does not change the number, but then it does make the number have 4 digits, 4 significant figures. That's why we have to write that extra 0 there to get the mark. Question 3. IME changes 250 euros into dollars. The exchange rate is 1 euro is $1.10. Calculate the number of dollars AME receives. So 250 euros into dollars is just going to be 250 times 1.10, which is $275. That'll be the answer. Question 4. The diagram shows 2 triangles, ABD and ADC. BDC is a straight line, AB equals AC, angle ABD equals 61, and angle ADC is 81 degrees. Work out angle DAC. We can notice that this angle DAC is in the triangle DAC, and we have one of the angles of that triangle already. So we can find the second angle of this triangle over here. Then of course we can find this angle. Well, we see that there is a 61 degrees given here. Why would it be given? Of course, it has to be related to the question. And we can see that these two lines, AB and AC, are equal in length. Therefore, we can put this together and realize that this isosceles triangle ABC means that angle ABC is the same thing as angle ACB, 61 degrees there. So this is 81, this is 61. Now you can find angle DAC. So angle ACB is 61 degrees since ABC is isosceles. And then angle DAC is equal to 180 minus 81 minus 61, and that's just going to be 38 degrees. That's our final answer. Let's go to question 5. Convert 0.17 meters squared into centimeters squared. Well, we know that 1 meter is equal to 100 centimeters. That means 1 meter squared is going to be 100 centimeters the whole squared. Why are we writing whole squared and not writing just 100 centimeters squared? I'll tell you in a moment, but first this is just going to be 10,000 centimeters squared. We have to square this and this. If you take a square, which is an area of 1 meter squared, so this is an area of 1 meter squared, so the side lengths are 1 meter and 1 meter. Now you want this to be equal to another square who has an area of 100 centimeters squared. So if 1 meter squared is equal to 100 centimeters squared, then these two have to be 1 meter as well. But then 1 meter is 100 centimeters. And if you multiply it, you'll get 10,000 centimeters squared. You won't get 100 centimeters squared like we want. So therefore, 1 meter squared is just 10,000 centimeters squared and not 100. So therefore, 0.17 meters squared is equal to this multiplied by 10,000, which is 1700 centimeters squared. That's our answer. Question 6. The mass of a solid metal cuboid is 4 kilograms. The volume of the cuboid is 600 centimeters cubed. Calculate the density of the metal, giving an answer in grams per centimeter cubed. Note that there's a formula given density equals mass by volume. Well, the answer has to be given in grams per centimeter cubed. So it's better if the initial values here are given in grams per centimeter cubed as well. So it's better that the initial values here are given in grams and centimeters cubed as well. This is already in centimeters cubed, but the mass is in kilograms. So you can just write that this is 4,000 grams, since 1 kilogram is 1,000 grams. So multiplying both by 4, we get that. And then we have the volume, which is 600 centimeters cubed. Now we can just find the density. The density rho, this is the Greek symbol, which is pronounced as RHO, rho. And this is, if you've known or studied physics, you would have known that this is the sign for density. And that's going to be mass by volume. You do not need to know the symbols. Even if you write this down, it's fine. But then I'm just writing it so that you will have some more knowledge about it. So that's going to be equal to 4,000 divided by 600. And when we cancel this, it becomes 20 over 3. And this becomes 6.66 or 6.67 grams per centimeters cubed. It's possible to do this without a calculator because we can just do long division for 3 decimal places and we will get 6.666. In fact, you would actually get 6.6666 and this just goes on like this. Or in other words, it's a recurring decimal with just a 6. Well, we can write this to 3 significant figures, 6.67, or we can even write 6 2 by 3, it's also fine. You can write 20 by 3 as well, it's fine as well. Question 7. U is equal to 3, negative 2. V is equal to negative 12, 5. A. Find U minus 2V. That's just going to be 3 minus 2 minus of 2 times negative 12, 5. That's going to be 3 minus 2 plus 24 minus 10. So that's 27 minus 12. Now for part B, find modulus of V. What does modulus symbol represent? In this case, it is not the absolute value. It has a different meaning in this scenario since we are dealing with vectors. Usually, if you put a modulus symbol or these two long lines around something, it means it changes everything to positive. So you put it around negative 1, it becomes 1. Put it around negative 2, it becomes 2. If you put it around 1, it doesn't change anything because it's already positive, so it becomes that. But then in this case, it means to find the length, the magnitude of the vector. It is the magnitude function. So the magnitude is going to be the root of x squared plus y squared. And this is the magnitude of one vector, of course. And that is going to be the square root of negative 12 squared plus 5 squared. That's going to be the square root of 169, which is 13. You might ask why this is 13 and not plus or minus 13, because the square root can take two values. But well, we know that this is a length function or a magnitude function. And how would you have negative 13 as a length? You can't, right? This is, as I said, it's a length function and we cannot have negative values for length. So it's only plus 13 or 13, that's our answer. Question 8. The diagram shows a semicircle with diameter 9 centimeters. Calculate the total perimeter of this semicircle. Give your answer in exact form. Well, if the diameter is 9 centimeters, that's just 2 times the radius. So that's 9, and the radius is 4.5 centimeters. Now, what is the circumference of a semicircle? And by circumference, I only mean the curved part, not the straight part here. This one we'll add on later. The circumference of a semicircle is going to be 2 pi r by 2, or just pi r, which is 4.5 pi. Now, the perimeter is going to be 4.5 pi plus the diameter value, which is 9. And of course, since you have to give an answer in exact form, we just leave it like this: 4.5 pi plus 9 centimeters. Question 9. In a sequence, the first term is 17, the second term is 12, the third term is 7, and the fourth term is 2. Find A, the fifth term, or t sub 5. We can see that between each term, there is minus 5, minus 5, minus 5, term to term root. So going from the fourth to fifth term, it also has a minus 5. And that minus 5 is here, so 2 minus 5 is negative 3, which is t5. t sub 5 is equal to negative 3. Part B, what is t sub n? That basically asks us to find the nth term of the sequence. So when n is equal to 1, t is 17. When n is 2, t is 12. And so on as the sequence continues. There is an easy formula, which is just a plus n minus 1 times d. And this is, of course, only for linear equations or linear sequences. This sequence has a term-to-term rule of minus 5, and this is the first difference. If this was a quadratic sequence, it would have an n squared term in it, and that means there would be a second difference here. So it could be like 2, 4, 6, 8, and the second difference would be 2, 2, 2. So these would be the first difference, these would be the second difference, and there would be some n squared term involved. But this one, there's no n squared. A and d are constants. A is the first term, which is 17, and d is just the common difference, which is in this case negative 5. And therefore, we just simplify this: 22 minus 5n. That's our final answer. Let's go to question 10. Question 10. Work out 2 2 by 3 plus 3 1 by 2. Give your answer as a mixed number in simplest form. We can first convert these to improper fractions. That's just 8 by 3 plus 7 by 2. Now, we can make the denominator the same. So 8 times 2 plus 7 times 3 divided by 3 times 2 by cross multiplying and then multiplying the denominators. That'll simply be 16 plus 21 by 6, which is 6 1 by 6 if you did it correctly. And that's our answer because we need it in mixed number. Question 11. Find the value of 64 to the power 2 by 3. That's just going to be 64 squared, but then we can cube root. And it doesn't matter which order you do this. So I'm going to put the cube root inside and the square outside. So we can do cube root 64. That's easy. That's just 4. And 4 squared, we get 16, and that's our answer. Question 12. Work out giving the answer in standard form. A. 7.1 times 10 to the minus 15 times 2 times 10 to the power of 3. So we can multiply the parts which are not in powers of 10. 7.1 times 2 is 14.2. Multiplied by this, 10 to the minus 15 times 10 to the power of 3. That's 10 to the power of minus 15 plus 3. And that's just going to be 10 to the power of minus 12. So 10 to the power of minus 12 there. And this 14.2 is 1.42 times 10 to the power of 1. And when you multiply by 10 to the minus 12, this will become 10 to the power of 1 minus 12, 10 to the power of minus 11. So that's going to be 1.42 times 10 to the power of minus 11. And that'll be our answer. Part B. 5.2 times 10 to the power of 7 plus 5.2 times 10 to the power of 6. We can write 5.2 times 10 to the power of 6 as First, I'll write down the other one. So this plus 0.52 times 10 to the power of 1 times 10 to the power of 6. This is another way to write this, because this 0.52 times 10 is just 5.2. The reason I did this is to make the powers of 10 both the same. We can also make this as 10 to the power of 6 by writing 52 times 10 to the power of 6, but that one requires one extra step because we have to convert it back into standard form. I'll show you how in a bit. First, let's do this method. That's going to be 5.2 times 10 to the power of 7 plus 0.52 times 10 to the power of 7. And we can factorize the 10 to the power of 7. So 10 to the power of 7 times 5.2 plus 0.52. That's 5.72 times 10 to the power of 7. And that's actually our answer, since this number over here is between 1 and 10. Let's say this is x, it has to be between 1 and 10. And what's the other method I was talking about? We can make this as 52 times 10 to the power of 6, and then we can factorize the 10 to the power of 6 from this, and we'll get 57.2 times 10 to the power of 6. But then we have to make this into standard form. It's not in standard form because 57.2 is not in that specified range of x, which is 1 to 10. So we have to make it as 5.72 times 10 to the power of 1 times 10 to the power of 6. So that's 5.72 times 10 to the 7, which is anyway the correct answer, but requires that last extra step, which is why I did it this way. But both methods are correct. That's our answer. Let's go to question 13.